Hey everybody, today we're going to take a look at literal equations, and our learning target is I can solve an equation for any variable. The homework assignment today is posted in Schoology. You'll use Cami to complete several literal equations for a given variable. Just a reminder, the test for this first unit, Unit 0, is going to be next week on Monday if you're in period 3 and Tuesday if you're in period 5, 6, or 7. Take a few seconds to set up your Cornell notes for today. You can pause the video and resume when you're ready. All right, first main idea is literal equation. So what is it? It's an equation with two or more variables. Typically, we've been dealing with only one variable lately when we solve one-step, two-step, multi-step equations, even two-sided equations. If it has x on the left and x on the right, that's still just one variable. So we're talking about two or more different variables. So examples might be formulas, are different types of literal equations, like y equals mx plus b, a popular formula used back in 8th grade Algebra 1 for the slope-intercept form. Or even a equals L times w. That represents the area of a rectangle, length times width. In each case, they're equations that have two or more different variable types. So how do I solve literal equations? The first thing you want to do is identify which variable you are solving for. Then you want to identify the operations and the order in which they were applied. We work backwards to get the variable by itself. Let's take a look at some examples. Example number 1 says m minus n equals 5. Well, normally we just solve for whichever variable's there, but there's two variables. So we have to look in the instructions. It says solve for m. So our job is to try to get m by itself. So what we have to do is look at what else in the equation do we have to move to the other side to get m by itself. M by itself. And in this case, we have to move the letter n to the other side. So we have to think about how is the n attached to the m? Well, the n was being subtracted from m. So if we want to undo the minus n, we want to use addition. We add n to both sides. And you might be thinking, well, how do I add n to 5? And it's a good question. And we do, but we don't really combine them because they're not like terms. What we're left with here is that negative n plus n is 0. Just as we've been seeing, when we move things, it cancels out over there. And we're left with m equals 5 plus n. Remember, I can't add those two things together. It does not become 5n because that would be 5 times n. And that's certainly different than addition. So in this case, that's our answer. We got n by itself. M by itself. M equals 5 plus n. Number 2, we have c minus 2d equals 5. Again, there's two different variables. We have to check the directions to see which variable are we supposed to get by itself. And it says here to solve for d. So if we're going to get d by itself, we're going to have to get rid of the variable c, and we're also going to have to get rid of that 2. So if we think of what's applied and how were those operations applied to the letter d, d was multiplied by 2, or technically negative 2, and then c was added to that, c minus 2 times d. So we're going to work backwards. We're going to start by moving the c to the other side. I draw my train tracks, and because c is positive, I can move it to the other side by taking it away. Let's see what we're left with. C take away c is 0. And when I bring down the 2d, I have to be careful to remember it's actually negative 2d. On the right-hand side, I have 5 minus c, which I cannot combine those because they're not like terms. I have to leave it as just 5 minus c. So we're getting closer. Remember, our goal here is to get the letter D by itself. So think about, how do you get rid of the negative 2 in this case? Well, it's currently negative 2 multiplied by D. So if we want to undo the multiplication, we would use division. Divide both sides by negative 2 gives us D equals 5 minus C all over negative 2. Now there is a way of simplifying that, but for today, I'm okay with that. The key today is to get the indicated variable by itself. Let's look at number 3. It says to solve for A, which means we're trying to get A by itself. So we're going to have to get rid of the 2 that was multiplied by A, and we're going to have to get rid of the 3b. Okay, think of that as one term, the 3b. We can move that all in one step. We're going to start by undoing the addition. We undo addition by subtracting. So that's going to reverse the impact of adding 3b if I subtract 3b from both sides. Since 3b minus 3b is 0, that leaves us with 2 times a equals y minus 3b. To continue getting a by itself, we need to undo the multiplication. So I divide both sides by 2. And I'm left with a equals y minus 3b all over 2. We solve for a because a is by itself. Here's number 4. Solve for m. This is a popular formula for the slope-intercept form of a linear equation, y equals mx plus b. This time, the variable I'm trying to get by itself is on the right-hand side of the equation. So I want to move everything else to the left-hand side. M times x plus b. If I work backwards, that means I want to undo the plus b first. So I subtract b from each side, and what I'm left with is y take away b equals mx, since b minus b is 0. You have to keep in mind what you're trying to get by itself. We're trying to get the m by itself. So on the right-hand side, we have to get rid of the x. To undo multiplication, we divide. Divide on both sides to keep it balanced. X divided by x is just 1, essentially canceling out since m times 1 is m. And on the left-hand side, we just bring it down. Y minus b all over x. Finally, if there are any questions, please feel free to reach out to me. I will be on the Google Meet for the duration of our class period today. You can email me. I will also be available during periods 2 and 4 for office hours, as I do not have a class at that time. Have a great day. Your assignment is posted in Schoology. Please complete the Day 6 assignment using Kami, or you can take a picture of your work on paper and submit it to Schoology.